So today we're going to build a blackjack game. And I'm hoping that through seeing this, you guys have a better idea of how to approach object-oriented programming. Because really, there's no lecture that I can give you. It's really just practice and understanding. No, you don't. But I have a mini evaluation you guys will do. It'll be relating to the game project. Just me getting honest feedback from you guys about how I can improve it for next semester. If you guys are feeling so compelled to give me an evaluation survey, feel free to here's what we'll do. Let's go to Discord. Where's my class Discord? Here we go. New channel, teacher evaluations. Because I'm not an actual teacher, but I do want to hear you guys' opinion. Chunks. You will get 5 points EC if you leave an honest evaluation. Like, don't just say, oh, he was great, he was awful. Like, don't be afraid to say I'm awful too, by the way. Just leave an actual honest review because it's going to help me be better teaching in the future. Things you liked, things you didn't like, things you would have liked to see differently, things that you thought seeing more would have helped you more, that kind of stuff. But yeah, everyone I see in there is going to get 5 points. I don't care how you do structure it. I'd rather like some kind of just verbose response. You don't have to give me an actual like point value. So, blackjack. As I was saying, with object-oriented programming, I think the best way to learn it is not necessarily like through doing lectures and say, do it like this, because I think that's a really dumb way to do it. And it's not a skill that you can just tell and learn. It's not like math, right? It's not like math where I can tell you the formulas and tell you what the numbers mean and you figure it out through a little bit of practice. It really is all just practice. And by that analogy, you guys have already learned what the numbers mean and your beginning stuff with Java. Now at this point is just putting it all to practice. So I'm going to build this. I will occasionally stop and ask you guys just questions about how to implement stuff. An approach, but for the most part, it is going to be a commentary. If you have questions, ask in the chat, or like somebody that missed the chat. If I don't answer your question in chat, just unmute yourself and ask. Honestly, unmuting yourself is probably the best way to get me to answer you quickly. But we're going to start. So the first place that I start whenever I'm starting a project is I think about my project. I think about whatever I'm trying to build, and I think, okay, what is the smallest unit that I can build into this thing? What is the absolute smallest unit that I can build? And I start with that. So in a game of blackjack, what's the smallest unit of something that we can build? What can we start with? What's the smallest thing that we can start with? Exactly, the cards in the deck. So we're going to start with card. And I'm going to have public string value and suit. I'm going to keep this public mainly just so we get some practice in on both. And I'm going to say private string array of values, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace, private string. And one thing to keep in mind too, ace can be a 1 or 11 in blackjack, so that is going to be something you have to think about later down the road. The card itself is probably not going to be responsible for that, and you'll see what I mean when we get to it. Suit. Suits. Clubs, diamonds, aces, and spades. Wait. Sorry, hearts. Hi, buddy.
This is a random question.
Sure.
How come you didn't choose character as the values, since they're all just one character?
I could do that. I just made it string, just cause.
Okay.
Yeah. No particular reason. Okay. And now the constructor. Int I values. Sorry, I suits. Int I values. Values equal to values at I values. And then suit is equal to suits at I suits. Cool. And we're also going to have two Boolean flags in here. Private Boolean is face up is in play. And by default, these will both just be false. I could have also put this inside of the constructor, but I'm not going to do that. I want to just make things, in my mind, more neater. Cool. And then what else do we need for the card? I'm going to have a public string toString method, which is basically just going to return us what the card is. So value of suit. So it'll be like 2 of clubs or 4 of hearts, etc. And the reason I'm having this is just so like I don't have to manually later on be like, you know, like card.value of, you know, card.suit. I don't have to do that every single time. I can just call the toString method and get the string back, which is nice to have. And then what we'll say is, what else? Oh, and then we should have getters and setters for the private stuff. So public void set face up. Boolean is face up. This dot is face up is equal to is face up. And a lot of this should just be review, but if you do have questions, let me know. And I will answer. But I think most of you are pretty set with getters and setters. Wait, what am I doing? Why am I doing any of this? Getter and setter for the 2 Booleans. Perfect. Awesome. Awesome. Anything else I need there? I think I'm set. So next we have to think about the deck. We need a way to have all of these in a collection. And right now, I'm not really so much concerned as how to call these. I just am thinking about their individual functions. So for the card, we need a way to represent the card. We've achieved this. And because blackjack involves the dealer having 1 card face down, we need to have this. And this exists so that I can query for cards in the deck that are not currently in play. So in the deck, we're going to have private card array named deck is equal to new card array of 52, because there's 52 cards in the deck. Private final int num suits is equal to 4, and then num values is equal to 13, because there's 13 values in a deck and there's 4 suits per deck. So for a total of 52 cards. Public card, and our default constructor, we're going to have int I is equal to 0. For int j equals 0, j is less than number of suits, not number of values, number of suits. That's going to be on the outermost. J plus plus. For int k is equal to 0, k is less than number of values, k plus plus. And then we're going to say deck at I is equal to, and it's suits then values. So new card jk. And then we will increment I. Turn type, what do you, oh, whoops. I named it wrong. Cool. So here's our constructor. And then what else does our deck need to do? What else does our deck need to be able to do? So we've constructed a deck of 52 cards. What does our deck need to be able to do here?
What about shuffle? Do we need to shuffle them?
We could have a shuffle method, but it's a real pain in the ass to just swap a bunch of variables inside of an array. So you could do that, but I don't want to do that. Instead of shuffling, what's another way that I can pull a card out from the deck? How can I mean, okay, I'm going to give away the answer, but yeah, I'm going to use random to pull a random card out of the deck. So I'm going to
draw a card?
Yeah, just to draw a card. So public card, we're going to say get or draw random card, Boolean face up, or I'll say is face up. And I'm going to import int I is equal to new random. And there we go. Dot next int. And we want this to be in deck.length. So what random.nextInt does is it generates a new number between 0. So the way we'd write it out mathematically would be 0 and n. And what this parentheses means is that it's the bound. So you don't include the bound. So meaning this is going to be generating numbers starting from and including 0 to ending with and including n-1. So deck, as we know, array length -1 is always the max index. Yes, inclusive 0, but exclusive n. Thank you, Diego. That is what that means. So it's going to generate random numbers between 0 and the max, essentially the max index in this, which is exactly what we want. And we will say while deck at I dot in play is in play. So if we generate a random number that is already being used, then we just want to generate a new index and try that. And we want to keep doing that. The second that this is false, meaning we've got one that is not currently in play, we can proceed because the while loop will not repeat. And then we're going to say, and we'll go ahead and set deck I dot set face up is equal to is face up, and then deck I dot set in play is equal to true. And then we were going to return deck at I. We're going to return this card. Cool. We have a way to draw a random card from the deck. And then we also want to reset, public void reset. So essentially what we're going to do for this is for each card in the deck, we're going to say card.sets in play is equal to false. And we're just going to do that for every single one. I don't really care about the, actually we should set the, no, yeah, we don't really care about the is face up because whenever we draw, we're already asking what it should be. So that doesn't really matter here. And I can, just to be tidy, it's up to you. You don't have to do that, but I like it. I like the way that looks better. So I do it without the brackets. And then remember, you can only do that if you have a single line in your for loop or your if statement or whatever the hell it is. That's only if you have a single line. Anyways, we've got the deck functionality and the card functionality. Now, I need a way. The next biggest object is what? We've got our card, we've got our deck. What's the next biggest object, single object in a game of blackjack? Yeah, exactly. Now, here's one thing I did with the other class, and I'm going to repeat it here. I'm going to create two separate objects, one for the dealer's hand, one for the player's hand. And very quickly, you guys are going to notice something. So let's get to that. Let's call this player. private string name. And then we'll have a private card array. Hand is equal to new card, length of 2, public player, string name. This dot name is equal to name. And then we'll have a method. I'm going to have a private int I is equal to 0. You'll see what that's going to be used for here in just 1 second. Public void deal card. I'm going to get a card in here, and we're going to say hand at I if I is less than 2. Hand at I is equal to card I plus plus. And this is how we ensure that we'll only ever have 2 cards. Cool. We're going to deal them a card. Public string to, I'm going to write a toString method just so we can convert whatever cards the player has to 2 cards. And I'm going to say card1 is equal to hand at 0 goes null. If it's null, then card1 string card1. If it's equal to null, then card1 is going to be just a blank. Otherwise, card1 is going to be hand 0 dot toString. And then we're going to repeat that for card 2. Oops, not 2 there, 1. Does everyone know what this is, by the way, before I proceed? Does everyone know what a ternary operator is? This thing here? Okay. What I'm saying here is I'm going to assign a value into card1, and that assignment is based on this conditional. So if hand 0 is equal to null, then if this condition is true, then I'm going to assign it this value. If this condition is false, card1 is going to have this value. Does that make sense? Okay. Stanley? Cool. Okay, awesome. That's a ternary operator. You see it used a lot. It's really, really helpful when you're assigning values, because then if you don't use that, then you do something like this. String card1 is blank. If hand 0 is equal to null, then we say card1 is equal to and then we'll say else card1 is equal to hand 0 dot toString. Look at that. 1, 2, 3, 4, 5, 6 lines of code reduced to one single line. How awesome is that? And that's why we do it. Because it makes things easier to read, because it's one single line. And you know, when you read it from left to right, it does kind of make sense in English, like, because we're assigning this value, and then we're checking this condition, and depending on that outcome, we're going to do this or this, right? Awesome. 6 lines of code into one single line. How great is that? We're going to say return. And we're only interested in their hand. So we're going to return a string that's card1 and card2. So it'll be like 6 of, yeah, I'm teaching black magic, exactly. So it'll be like 6 of clubs and ace of spades, for instance, is what this string will return. Cool. Now let's think about our dealer object. I'm gonna make a new object here called dealer. So these classes, I'm just concerned about capturing the dealer's hand. So if I really think about it, wow, the dealer is actually going to be pretty similar to this, because if I'm only concerned about this class representing what's in the dealer's hand, then, you know, we can give the dealer a name. Sure, that's no big deal. The dealer's going to have 2 cards in his hand. One of them will be face down, but that's handled elsewhere. We're going to have to use this as well. Did you guys do inheritance in 210? Or do you just know what inheritance is, Juvenile?
Yeah. I just know what
220.
it is.
Okay.
Not right now, okay? Let me finish teaching and then we'll go out.
Okay, guys. Hello. But yeah, if we really look at this, this can be the same class. So instead of calling this player, I'm going to rename that. Refactor, rename. I'm just going to call that hand. Yeah. So we've got all of our basic objects. Now I'm going to create a blackjack class. Oh, and sorry, one thing to consider. The hand also, we need to be able to get public int get hand value. Or hand value, let's call it that. So int value 1 is equal to 0 and value 2 is equal to 0 to begin with. So what's going to happen here, we're going to check for a few things. Let's see. Oh, I actually have like a really easy way to do this. Int val1 is we'll use ternary operators again, and we'll say hand 0 equal to null. If it's null, then this is 0. Otherwise, public int card value card. So way better than what I did in the previous class. I don't know why I didn't think of this then. Card value of hand at 0. So if this card is not null, then we're going to send that in. And we're going to do the same thing for value 2. We're going to do that with hand index 1. And here we're going to say if how do we handle 11s in this case? See what we'll do. We'll say int I, we'll say 0, 0, 1, 1. Because I need a way to handle aces being 1 or 11. I'm working right now. Huh? 1 second, guys. Sorry. This one is kind of tough. Well, let's see. Okay, I know how we'll do that. Yeah, okay, I have an idea. So for now, we'll just be concerned with just a single value. If we don't need that anymore. Sorry, this is probably confusing to you guys. You have no idea, but I'll explain here in a second. If card dot value equals jack, so if it's a face card, or queen, or king, if it is a face card, then we return 10. Else if card.value equals base, we're going to return 11. Else, otherwise, we're just going to return integer.parseInt card.value. Because if it's not a face card and it's not an ace, then there's only one thing it could be, and it's going to be something that we could use the parseInt to get into an integer, because that is how we could turn a string into an integer. So, what don't you like here? So now here what we're going to do is we're going to check if it's a face card, if it is an ace. Actually, I don't even need to have those if statements. You guys already can just read code and know that. Something I mentioned to the previous class, comments are kind of like putting black truffle in your food. You don't want to put a whole bunch in there. You guys do not need to give me comments for every single line. I do not want to read comments of like, this line does this line does that. I know what the line does, I can read. The comment should be more so there to maybe like if something of your, maybe one of your methods is a little more complex, like you can explain, or like you want to explain its usage, for instance, or you want to just kind of have them be like guides in the flow, something like that. You don't want it to be too intense of what it does. If you're doing some weird conditional checks, maybe at the beginning here, be like, hey, this is just error handling for blah. But it should just be a very simple one-line code. You should input a statement to return either 1 or 11 for A. I'm about to. The value depends on whatever we get here. So if value 1 is equal to 11, else if value 2 is equal to 11. So we're going to have two things that we do here. So if value 1 is equal to 11, and actually we could do that in a single conditional. So we're going to say if value 1 is equal to 11 and value 1 plus value 2 is greater than 21, then we're going to say value 1 is equal to 1. Else if, same exact thing, except for value 2, then value 2 is equal to 1. And I guess we can make things a little neater by removing the brackets. Again, you don't need to do that. You can leave the brackets. I really don't care. I'm just being picky right now. And then we're going to say return value 1 plus value 2, because that is the value of our hand. So we can divide between hand value and card value. And there we have the perfect conditional to check how we convert an ace to a 1. And I don't really care about splitting, so I'm not going to check for that condition, because in this game you can't split. You can only hit or stay. We're going to make a very, very basic blackjack game. Cool? Cool. So now let's get to our main driver class. Public static void main string args. And we're going to, first of all, we're going to have our scanner object equals new scanner system.in. And then I'm also going to create our deck object. Deck equals new deck, because we only have a default constructor in there. So we've constructed our deck and we've built our scanner object. So let's start our main game loop. Main game loop. While I'm just going to make it true, because I'm going to use break statements to control the flow. Obviously, as I always say, there's multiple ways to do anything here. If you guys can think of, you guys can use actual conditions to check, whatever. I'm just going to make mine based off of break statements. And then hit stay loop. That's going to come after we deal. So first we do the initial dealing. And for the initial dealing, we need hands. So hand player is equal to new hand, I'm going to say scanner, oops, system.it, system.out. We're going to print out and ask, what is your name? And then hand is SC dot next line. And then hand dealer, and I'll break that down what I just did above in just 1 second. And dealer. So another way you could have done this is to just say, okay, string input is equal to sc dot next line, and then say hand player is equal to new hand inputs. But I can just condense that into one single line. So that's what I'm going to do instead. But I'll leave that there as comments just so you see how we could break this down if I wanted to. Is anybody confused about this right here? It again just falls into the thing. Instead of using 2 lines of code, I want to use 1 line of code.
Can you repeat it again?
This down here, the commented part, is exactly the same as this.
Oh, okay.
So instead of having it in 2 lines where I put the input into a separate variable and then I put it in here, I just do it as 1 line just because I've been doing Java for a while and I do little things like that just to cut out lines of code. It really doesn't make a huge difference in your code one way or the other. There is 0 functional difference between these two. There is no difference in memory or anything. It literally is just for me, I would rather read 1 line of code instead of 2 lines of code. But you guys, if you're more comfortable with this, then just keep doing that. Don't feel that you have to do the little things that I'm doing here, right? If you think it's going to confuse you, do what you know. So the initial dealing is going to be player dots. We're going to deal a card. And we're going to say deck dots draw a random card. And for the player, it's going to be true. The first card we deal for the player is true. It's face up. Then dealer gets a card here, and then false. The order here doesn't really matter. I'm just doing it based on a casino. In a casino, they'll put 1 card down for the dealer, then they'll give it to the player, and they'll give it back to them, put 1 for themselves, and their card is always 1 face up, 1 face down. Oh, one thing I forgot about here. In getting the hand value, I do need to consider if a card is face down. So instead of doing this, I actually do need to break this down into multiple lines because I need to check for multiple things. So if hand 0 is not null, if it is null, if it's null, we don't care because the default condition is already here. If hand 1 is not null, and actually, wait, hold on. Could I do this? Could I do compound conditionals in here? So if I do like hand 1 is not null, and 0 dots is face up. Will you let me do that, Java? No, I can't do that. Oh, the DOI. Oh, I can do that. Awesome, perfect. So I'll just instead do that as a compound conditional up here. Hand 1 is face up. Method invocation is face up will produce null pointer exception. Oh, okay, so I can't do it that way. No, I have to do it the other way around. Int val1 is equal to 0, val2 is equal to 0. And then I'm going to say if val1 is not equal to null. Oh, oops, sorry, that's JavaScript. Oh, it is right. Never mind. JavaScript is 3. Oh, sorry. Hand 0 is not equal to null. Perfect. If hand 1 is not equal to null, then we're going to say, oh, right, that was JavaScript. Hand 1 is not equal to null. We're going to say if hand 0 dot is face up. Value 1 is equal to card value and 0. We're also going to repeat this for the second card in our hands, and that's going to be value 2. Oh, I forgot semicolons here. Awesome. And this is how we check to make sure we're only getting values if the card is face up. That way, regardless of if our card is face up or face down, we are ready and able to handle it. Cool. Nice, clean, easy to read code. So we've dealt cards. Dealer has 2 cards, player has 1 card. So I'm gonna have a second loop here. That's gonna go through the player hitting or staying. Print. Your hand is player dot toString, because this is the player hand, right? And if we split this vertically so we could see, if we look at the toString value, it's just going to return what the card 1 toString, card 2 toString is. And if we look at the cards toString method over here, it's going to return value of suit. So 2 of clubs, 3 of hearts, etc. So we tell them what their hand is, and in parentheses we'll put value is close parentheses over here. I'll put, let's say, player dot hand value. We'll calculate their hand value. Snap print. Dealer's hand is one moment. I need to change something over here. If it's not face up, then we're gonna actually just say return. That's cool. Dealer's hand is dealer dot toString. Actually, I can use exactly the same thing that we used up here. Dealer's hand is, and I'll replace all these with dealer and dealer. Cool. And then we're going to ask the user, do you want to hit or stay? And I'm just going to assume for our purposes that the player is not going to answer anything weird. So we're going to say string input is equal to sc dot next line. We're just going to assume that they're going to say either hit or stay. If input to uppercase equals stay, then we break. We break out of the hit or stay loop, and then we need to have the dealer hits stay loop. Dealer, so the way in a casino, a dealer will always hit until they get a 17. Or the dealer will always hit and they will only stay on a 17, I believe, right? Can anyone remind me? I do believe that's the rules of blackjack. Dealer hits on 17, or dealer hits till 17, right?
I think so.
Wait, what's 17? Isn't it 21?
Your objective is to get
Dealer has to
21.
hit, yeah.
In a casino, the dealer behaves in like a very linear way. to give you a chance to win. So basically, if they'll stay on a 16 or 17. Let me go. That's not what we're after. Blackjack, dealer, stay. In a casino play, the dealer has no options. He always has to hit values below 16 or 17. So we'll just say in our casino, they'll hit any value. Hold on a second. Sorry, guys. Let me close the door. Our dealer will hit anything below 17. That's the dealer's logic. So while dealer hand value is less than 17, we're gonna keep. Oh wait, the dealer can have. Shoot! God damn it! The dealer can have more than 2 cards. That's really, really annoying. Okay, so I do need to actually divide these up. So we're gonna refactor this to be. Oh wait, even the player can have more than 2 cards in there. God, that's annoying. Okay. You guys are gonna learn something new today, okay? You guys are going to learn something new today. I'm gonna keep this as hand and private array list card. You guys are gonna learn a brand new data structure today. An array list does not require equals new array list. An array list works exactly the same as array type expected. Oh, right, array list. I don't need that, so hand.add card. An array list does not have a type. Sorry, not a type. That's not it. Sorry. Let me just rechange this code, and then I'll tell you what I'm trying to say. An array list is a data structure in Java, and the nice thing about array lists, they work very, very similarly to arrays, and you'll learn more about array lists in 220. But for now, I'm using them because I can't really think of an easy way to make the code work without it. These are supposed to be 0. Okay. Cool. So, card. Okay. Let's go to Google real quick. Let's go to our old friend Google. Java array list. Array lists work very, very, very similarly to arrays. The only difference about an array list is that instead of manually setting your array size and querying specific arrays, an array list is a class in Java. So we need to use their methods to do stuff. So to add, we can add an element to the end of the list, and it will dynamically size the list up. We can use add element E. Whenever in these documentations you see E, this is just a generic object. It's a generic type parameter. It just means it can be of any type. That's all that means. And then you have another add, which you give it an index, and then whatever object you want to add into the array list. A bunch of other really cool functions that you have. But if you're doing something like what we are here, where your array can be a variable size depending on how much you add, we want to use array lists instead. Now I could have done this with normal arrays just by allocating a bunch of space, but I don't know how many cards potentially you could have. Actually, here's what we're gonna do. I'm gonna keep it like this. I'm gonna keep it like that, and then all we're gonna do, we're gonna have a public void reset hand, which is just going to be equal to hand.clear. Now I feel really bad about using a data structure you guys know nothing about, because this is going to lead to people being very confused in an already very confusing thing, and I'd rather you guys learn the underlying technology here. Okay. All right, I'm going to delete all this code and start fresh because, yeah, I need to rethink some stuff. Restart this. N. N is a number of elements in here. Card hand is equal to new card. And we're going to say we're going to allocate space of up to, I'm just going to say 52. I'm just going to say you can have up to all the cards in the deck. Okay, and then N is going to be used to track how many cards we actually have in our hand. So public hand string name, this name is equal to name, and I'm going to go ahead and say public void add card. If n is less than hand.length, or we can, here's what we'll do. Instead of hard coding this value, I'm going to say private final int max cards is equal to 52. And we'll initialize that up here. Actually, I'm gonna move that up one more line just because neatness, formatting, whatever. If n is less than max cards, then we're gonna go ahead and hand at n is equal to card and plus plus. Otherwise, we're not going to do anything, and we're going to go on with our lives. Obviously, we're never going to get up to 52 cards, but that's fine. Public void reset. So we're going to go for card, and for each card in our hand, we're going to say, when we reset, we're going to say card, wait, no, it's not for that. For int I equals 0, I is less than equal to n. Wait, no, it should be less than n, because whenever we're done, n is always going to be one higher than our current index. or the max index. It's always going to be pointing to the next. So let's say less than n, I plus plus, and then we're going to go, we're going to say hand at I equal to 0 or null. And then at the very end, we're going to set n is equal to 0. I'm sorry, n back over at 0 because we have no more cards in our hand because we've gone through and set everything back to null. Okay, that works. And then we need to write the deal card. Here, we'll just use the same name. Deal card. And then we need a hand value. Public int hand value. Okay. Just for the sake of our game, aces are only worth 1, okay? Can everybody get behind that? I don't want to have to deal with this 1 or 11 stuff with this data structure. So just assume for our blackjack game, aces are equal to 1. So we're going to say int total equals 0. And then for int I equals 0, I is less than n, I is plus plus. Actually, I do it like that just to be consistent with my spacing. Total plus equals card value for hand at I. And we're going to have a method here, public int card value card if card dot value equals jack or value equals queen, king. If it's a face card, return 10. Else if card dot value equals ace, return 1. Else return integer dot parse int at card dot value. Okay, awesome. And after we're done getting our total, we're going to return total. So let's go back to the blackjack one. Everything is good. And so if they hit, so here is if they stay. If they hit, then we're going to say player dot deal card deck dot draw random card true. Oh, we have to go back here and say if card dot is face up. If card is not face up, meaning it's face down, then we're going to return 0 because we don't know what that value is. Otherwise, we're going to go on checking through here. Cool, 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 cool. All that works, should work. Come back here. Going to deal the player card. And then over here, we're going to say if player dot hand value is greater than 21, then we're just going to tell him you bust You lose. Public, oops. Boolean player win is equal to false. Dealer win is equal to false, while player win, while player is not winning and the dealer is not winning. While both these guys are losing. You bust, you lose. Player win is equal to false. Wow. Player lose. And dealer lose. Player lose is equal to true. And then we break out of this inner loop, out of the hit stay loop, and break out of this loop, and then over here we're going to say if player lose, we're going to break just because we need to do the double break. Otherwise, we're going to continue along. For player, dealer hit stay loop, dealer will hit anything below 17. While their hand value is below 17, the dealer is going to hit dealer dot deal card deck dot draw random card is face up is true. And then I'm going to say and say public void flip card. Let's say flip card at this index int I. If hand I is not equal to null, want to make sure we're never querying a null one. Say if hand I dot is face up, then hand dot I set face up is equal to false. Else set it to true. Cool, and that is what that will do. So we'll say over here, dealer dot flip card at 0, and then the dealer's hit till 17. We're going to flip the beginning card. Actually, we'll do a check here before the dealer even flips their card. If dealer dot hand value is greater than 21, I'll print dealer busts break. I'm just going to keep this as true forever. Player lose is equal to false. You're going to reset that. Otherwise, if they don't lose, if no one's lost so far, then dealer's gonna flip the card, and dealer, and so there's a few things that can happen here. if their dealer's hand value is greater than 21, dealer loses, dealer busts, and then, oh, hold on a second. Lose, dealer lose, false. We'll say over here, dealer lose is equal to true. Same exact thing over here. And the reason why we have this twice is because this is just a check. If they lost while they were hitting, then they flip the card. And if they're over 21, then they lose. Else, if the dealer is not 21, is not over 21, if player dot hand value is greater than dealer dot hand value, print you win, and then same thing over here. We're just being explicit with our conditions. And else, if player dot hand value is equal to dealer dot hand value, I'll say even values, house wins on draw. I'll just say house wins on draw. Okay, and then player lose is true because you lose and the dealer is the winner. So dealer lose is false. And then over here, we're going to say in, play again, yes or no. If input or CSC dot next line to uppercase equals no. If they don't want to play again, then we're going to break out of the main loop. Otherwise, we are going to deck dot reset player dot reset dealer dot reset. We're going to reset all our hands and we're just going to play again. Okay, that was a lot of code. We crunched out a whole hell of a lot of code, and there are still some logical faults because we're not checking if the dealer hand is equal to 21. I could put it here if it doesn't matter. I'm not going to worry about the blackjack right now. There are certain things of blackjack that we're not doing here, like you normally win immediately when you get 21, but I've been hard coding for a little while now. My head's tired, and normally if I was doing this myself, I would not use these data structures. I would use different data structures that would be easier to work with. What is your name? Turk. Your hand is, oh. Why did it do that? Dealer two string. Oh, we don't have a two string method. The doi. Public two string. String. Two string. Your hand is four int I equals 0, I is less than n, I plus plus. If I is greater than 0, then system out print, I put a little comma at the end there, at the start of it. If we're greater than 0, I'll just align that like this. And then we're just going to print out string re equals empty string, or blank string. We're going to append into that string and I dot to string. Card to string. Cool. And then return re. Now if we run this again, it should print out right. Turk. Oh, wait, what? Eight of diamonds. Something went weird there. Let's find out. So we're going to put, so our code just behaved in a really weird way. My print came out really weird, and I'm wondering why that is. So let's check the debugger. So this will be good practice to use the debugger. What's your name? Turk. Let me come here. So this, our hand, is just a single card, which is a K of diamonds. So I equals 0. I is equal to 0, n is equal to 1. I is not greater than 0, so it shouldn't print out the comma. Okay. So we print that out. How do we get that string? Okay, we return re the K of diamonds. Your hand is. Why did you print like that? What? Where the hell is this coming from? That's so weird. Why are you like this? My name is Turk. I'm gonna layer that to string. Raise 8 of diamonds. Okay. I don't understand. It printed right after I entered name. It's just being really odd. Like this value that we're getting here for the dealer is also incorrect. No. I'm not confused about the question mark. I'm confused why it's not printing out like that, and then J of diamonds. That's what we expect it to be. That is what we expect the toString method to be. Oh! I think I know why. Override. And let's do that also for the card. We have to override it because toString is a default Java library call. So I think if we do the override, we might get rid of those weird errors. Let's find out. I'm hoping we do. Turk. No, it's still being weird. And that is really odd. It shouldn't be doing that. Which one has the main method? This one. Blackjack. That's her main driver. But it's not something in here. It's being really, really strange. This is not like a normal error. This is not a logical error. This is just something that's really weird. Okay, we're just gonna rename these to getString. And this will also be getString. And then we can get rid of the override command because we don't need to override it anymore. Player.getString. GetString. GetString there. Anywhere else we have a toString. And then the hand, that will be getString as well. Okay, no, it has nothing to do with that. Oh, I know why. I think I know why. It has to do, it must then have something to do with not, toString. Maybe it has something to do with the print statements. Or you know what? Here's what we're going to do here. I think I might know. Let's try that. And then I think it's because I'm forgetting the new lines here. Maybe that'll fix it. Wait, where's the error here? What don't you like about this? Why are you giving me a little red underline? Whatever. Let's run the code real quick. Hopefully that works now. No. Doesn't. No, no, you're just guessing random things now. That's not, no. No, this definitely shouldn't have a new line because we're using it in a line. So these do not need to have new lines. Like a blank, and then print those all out in a single line. Your hand, dealer's hand is, your hand is. Okay, you know what? We'll just ignore that for now. I have no idea. I've never seen a problem like this before in Java. Let's just rerun to make sure the actual functionality of the game works because we're running out of time. I have no idea why it's printing like that. You want to hit. It is working too, though. Even though the formatting is really weird. It is doing the math right. You bust, you lose. Awesome. Okay, the basics of it works. The game itself does work. Now it's just figuring out why it does this. So maybe... why does it put it... The question is, why is it putting that comma in the beginning of this string and not... Oh my fucking god, I'm so stupid. I figured it out. Because I was using a print statement here and not appending it to the string. So now if we run it, it's going to print like we expect. Yeah, in a string method, in the toString method, we're building a string. We're not doing prints. That was the issue. Let me know if that didn't make sense to you. See, now it's printing how we expected because we're not doing system out print the comma in the beginning. We're actually adding it to the string that gets returned. So I have 5 of spades. I want to hit. I got an ace of clubs. I want to hit. Got another ace. Hit. Do another hit. Let's hit one more. I bust and I lose. Cool. But our game works. We have built a fully functioning blackjack game. Do you guys want to review the code? Do you guys want me to go back through, talk about where we started, what we built? Or are you guys' brains just totally fried right now?
I want to go back to why you changed the logic for the ace.
Oh, because I'm lazy and I don't want to do... so here's what's happening right now.
Okay.
I'd have to get into this issue where I do recursive calls. So
Yeah,
if we
that's
go
what I
back,
was thinking.
yeah, if I go back to the hand, hey buddy. Oh. If I go back to the hand, if I encounter an ace, to dynamically change it to be 1, I have to go back through the entire deck and be like, I have to go back through the entire deck or the entire hand and minus the aces and count, hey, would this be greater than 21? Right?
Okay, yeah.
And that would have to be every time I encounter an ace, I would need to have some kind of logic for that, and I really don't want to deal with it. I'd have to put extra stuff in there, so it was easier for me to just say aces or 1s instead.
Oh, well, isn't it in blackjack you choose whether it's 1 or 11?
No, you don't choose it.
Oh, I thought...
You always take, because you want the highest number, right? So if like you have by default you pick what the best outcome for you is. So you as the player don't have choice over it. The game or the dealer, aka the game, should be deciding for you what the best possible use of that ace is. Does that make sense?
Yeah. Okay. Oh, okay then.
So that on our end of the programmer would have to involve us having to do some extra code that I really I just don't want to deal with it right now.
Yeah.
So it was easier to just have it be ace. Plus the whole point of this program was to just get you guys more practice in using object-oriented programming for all this stuff, is getting used to looking at a real-world problem and thinking to yourself, how can I break this down to a Java solution? How can I, if I look at a car, let's think about that for a second. If we look at a car, what are the different parts of it? There's the wheels that drive the car. There's a fuel tank that has fuel in it that gets spent as the car runs, all this different stuff all comes about from, what do you call it? Just these little parts working together. It's all of this is just to train you guys to get in the habit of looking at a complex problem, looking at a complex thing, and breaking it down to simple parts so that you can model that problem with objects. Because if we think back to why we do code, it's to create solutions. It's to create digital machines in a sense. Like
Oh, okay.
back in the day, we would create robots, not robots, but like factory arms. We would create tools, whatever, to fix a problem. Now we do this in a front of software. Any other questions about the code that we created today? I will be posting this on iLearn, so don't you worry. You guys will be free to play around with the code on your own. I highly encourage that you do. One thing that I often say to my class, a lot of you guys come to me with questions of what would happen if I did this. You don't need to ask that to me. You have a tool in front of you that you can actually test that out in. And if you don't want to completely mess up your code, you can try to separate that into an isolated problem. If you go to a website like Replit and look for Java, so I'm going to log into my GitHub account. Also, I encourage you guys to make GitHub accounts and start playing around with GitHub because it's great. Your REPL, Java. I can come in here, and this is a totally isolated environment away from your code, and you can just like break down your problems in here and run the code in this terminal. It's great. It's an awesome tool to have. It's an awesome tool to use. It's really just a great way to, if you have questions in your head of like, how would this work, but you don't really want to mess with your main code, it's really fast to just open up a Replit window and directly work in there. So all this to say, questions like, how does this work? What does this error mean? What would happen if I blank? You guys have the tools to answer these questions for yourselves. You don't need to ping me or other people in the Discord about it. You could just test it and see. So that's my whole spiel. Any parting thoughts or questions?
Oh, the overrides. I've always got confused
Mhm.
between how they work. So is it mainly just for default functions, or can you use
It's
them?
for so it kind of comes into play with inheritance. That's why we don't talk about it as much here. We use an override here specifically because toString exists as a default Java method.
Mm-hmm.
So all of these custom objects we create, they actually inherit themselves from the Java object class. That's the most generic object that there is, most generic value in Java that there is, the object variable, the object class. And within that object class, or somewhere within Java library, is a method called toString that by default does something of its own, but we want to override it, so we have it. We change the implementation here. So we have a very specific way that we want the hand to be represented as a string, and to be able to do that ourselves, we tell Java, hey, whatever you want to do with this method, don't do it. Because if I don't have this, I'm going to get an error, or I won't get an error, but there's a chance that like it will default to the Java implementation. So by me having override here, it's just me telling the compiler, hey, I know you have another method like this existing somewhere within you. Use my version. Don't worry too much about this now. Like, you can really get by right now with just me telling you, hey, when you use the toString method in one of your classes, you need to put the override. That could be like the simplest answer to your question right now. When you use toString, just use that. That's all you need to know for now. Once when you guys get to inheritance, you'll learn a little bit more about what override actually means. Any more questions? I encourage you guys to go back through, watch this video, watch the development process, watch how I use the debugger, try your best to kind of follow along with what I was doing and why. I know I wasn't like really saying much or articulating thoughts very well, but try your best to, if you have questions about it specifically, like, send me timestamps or whatever of the video and I'll try to answer it. But yeah, you will have an assignment this week. It's going to be the review lab. I just need to make changes to it because the original review lab has you do inheritance, and you guys haven't learned you guys don't do inheritance in 210. So I need to change that around. You're probably going to make you're going to model a car using Java. Is probably going to be your assignment. I'll be putting that up by the end of the day today. I just need some time to actually write it out because I forgot to check the lab before coming into class today. Any other questions? Okay, well, if there's nothing else, that'll be class today. I'll pull up the video on the YouTube as usual. So yeah, good luck, everybody.
All right.
Thank you.
Take care.